Okay, time permitting, I'm going to throw back to that question 10 here. I don't seem to have my yellow here. Let's make it. There we go. All right. So in the set 3 problems in 1.5, not a ton to say here, although there's maybe an interesting point here to add to my little question mark as pictured. We've Joe's 15 years of age and a star of the track team. Accordingly, which is a conclusion indicator word, tells us that the conclusion is he will probably be able to beat his 10-year-old brother in a foot race. Sounds plausible, and it should. That's why we're going to say that it's inductive strong. Now, inductive because there was the word probably, an indication of probability, that the conclusion is being asserted to be likely true, not necessarily true, granted the premises. Okay, so that puts us with an inductive argument. Why is it strong? Well, if Joe is 15 and he's a star of the track team, then odds are, overwhelmingly so I would say, is going to beat his 10-year-old brother in a foot race. Maybe not. Maybe his 10-year-old brother isn't an amazing prodigy, but we don't have any information like that based on what we have. Oh, I don't know. I'd put it about a 99.7% chance that he's going to, in these circumstances, granted these premises, beat his brother in the foot race. Now, maybe you see I say that partly as a joke. You can't read it very well. There really is no way to put an exact number on it, and induction is a little bit dicey, sort of less clear, less mathematical, kind of loosey-goosey like that, in a way that deduction is not. All right, final question here, number 9. We have since. I should have circled the word since, premise indicator here. We had premise and conclusion indicator. It follows that. I have a fancy, well, not too fancy, little dotted line between it follows and that. Sort of technically, that's the whole conclusion indicator. Our conclusion is that Pittsburgh is 6 miles from Columbus. Now, what you don't want to do is shut down and say, well, that's obviously false, and then make some kind of determination, because you're not really then thinking about whether or not the reasoning is correct. Oh, yes, let's see here. Let's circle it nice and yellow. Make sure you use the flow chart on page 15. That's crucial. And if you look at that chart, the truth of the premises is only something you should consider if, in fact, we find out the reasoning is correct. Now, for example, that's true in number 6 here. That's true in number 4 here. In 4, you'd say, well, I can't tell whether or not it's cogent. You don't know who Joe is. What we can say is that the reasoning is strong. Similarly, no way to tell whether or not the premises are true in number 6. The important thing is to recognize that it's valid. Truth of the premises in number 9 in the end doesn't matter. It's invalid. And the reason is because of something like this little picture I drew right here. We could have the premises true. I have Columbus and Cleveland 1 mile apart. And I also have Cleveland as 5 miles from Pittsburgh. 4 plus 1 is 5. But in this case, it is not so that Columbus is 6 miles from Pittsburgh, or Pittsburgh is 6 miles from Columbus. Those are the same claim logically. In fact, they're 4 miles apart. They don't have to lie in a straight line either, so we have all kinds of numeric possibilities in this case. Reasoning's no good. The argument is deductive, invalid. In a different problem, if somehow the reasoning was correct, but at least one of the premises were false, then we would say that the argument is valid but not sound. All right, quickly, I think I got a moment here. Why is the argument pictured right here? All G are A, some A are D. Therefore, some G are D invalid. We could have, in general, everything that's G being an A. We could have some things that are A's that are D's without having some G's that are D. Maybe the A's that are D don't happen to be G's. And the first premise just says that everything's a G has got to be an A and not necessarily vice versa. And that's the gap. That's the logical gap here. To use some of the content, maybe all grizzly bears are in Alaska. Okay, that could be true. And it could be that some things in Alaska are dangerous. Maybe the polar bears. And yet, we could have the conclusion false, those two things together. Now, our own information might tell us that some grizzly bears are dangerous, but that's just ignoring the argument. To the premises tell us the conclusion's got to be true. No, that's why it's invalid.